Okay, so that's arrow functions in a nutshell. Now let's move on to the next topic in this lesson, which is function hoisting. Let me delete all of this code. And what in the world is function hoisting? Well, let me show you an example. Let's imagine we have a function named cool. And maybe it just logs out to the console a bit of text that says, "This is super cool." Okay, now imagine right above this function declaration, up on the very first line, I try to call the function. If I check the console, we see this is super cool. So our code is working successfully. However, the only reason this code works is because of function hoisting. What I mean by this is usually the ordering of our lines matters in JavaScript, right? Like if down here, I created a variable called strawberry count and set it to 100, I can only access the strawberry count variable below this line of code, right? I can't expect to be able to access strawberry count before it's been created. So if above this line, I tried to log out to the console strawberry count and then try to check the console, we see uncaught reference error, strawberry count is not defined. So clearly the ordering of our lines matters. So the question is, why are we able to call this function before we've even created the function? Well, the answer is because JavaScript has something called function hoisting. As far as JavaScript is concerned, this section of code might as well be up at the very top of our code. Hence the name hoisting, right? We can consider this code hoisted or moved up to the very top, even though it's not there physically in our code. However, not all functions get hoisted. So yes, a function declaration like this will be hoisted. A function declaration is where we actually use the keyword function and give it a name. But we know that there are other ways to create a function. So check this out. What if instead we create a variable and call it cool and set it to equal an anonymous function, right? So function parentheses curly brackets, and then we try to log out to the console and say, hey. Well, if we check the console, we just see uncaught reference error, cool is not defined. So just be aware that unless you create a function with the actual keyword function and then the name, your function is not going to get hoisted. So in this case, with this example, we would need to call the function below where we are creating the function, like this. Now it works just fine. So big picture, with a traditional function declaration, you can get a bit lazy with the ordering of your lines, but if you create a function in any other fashion, you need to pay attention to your line order. Okay, now let's change gears. So that was function hoisting in a nutshell. Let's move on to the next topic in this lesson, which is template literals. So what in the world is a template literal? Well, I'm going to delete this code and start fresh. So let's imagine we have a variable called myname, and we set it to equal whatever your name is. And then imagine we want to log out to the console a bit of text that says, hello, my name is blank, right? And then it pulls in the variable. And then we also add on, and the sky is blue. Right, so if we check the console, all together we see that that pulls in the value for the myname variable. So our code is working as we would expect, but this syntax can be really awkward. I'm sure if you're being honest, there was a point throughout the course so far where you got frustrated with the having to open up a quote and then close the quote and then plus symbol, variable, plus symbol, new quotes. It just gets awkward to type and it's not ideal. So right now I want to show you a new tool called a template literal, which is going to make our life a lot easier. So let's get rid of this entire string of text and instead use two backticks. This character is directly to the left of the 1 key or right above the tab key. So instead of a string of text, we would call backticks like this a template literal. But really, we can just think of it as a string of text with superpowers. So check this out. We can just say, hello, my name is blank and the sky is blue. Now, obviously, we don't actually want the word blank here. We want to do something dynamic. We want to include an expression, or we should say we want to pull in the value of this variable. So within a template literal, when you want to do something dynamic, you just include $, curly brackets, and inside here we can include an expression, or I should say we can do something dynamic. So instead of just a string of text that's going to be interpreted literally, we could say 2 plus 2, and this would say, hello, my name is 4, or what we really want to do is just pull in the variable. Awesome, so that gets the job done, and in my opinion, this is so much easier to type out and work with. We don't have to use the plus symbol, and we don't have to keep dropping in and out of the quotations. When you want to do something dynamic, you just say $, curly brackets. And remember, to create a template literal, where we have this superpower, we just wrap our text within backticks instead of regular quotes. Okay, so that's template literals in a nutshell. Now let's move on to the final topic in this lesson, and that is semicolons. So let's give ourselves a goal. What if we wanted these 2 lines of code here to be squished together and just sit on a single line of code that's really long? So we could just delete the white space like this. But this is not valid JavaScript. This is throwing an error. JavaScript cannot make sense of what we are trying to do here. However, where my cursor is right now, if we just place a semicolon, everything's fine. This is perfectly valid JavaScript code. So the idea is that a semicolon is sort of the period at the end of a JavaScript sentence. It's our way of taking a breath or letting JavaScript know that this thought is complete. Now here's the interesting part. Without the semicolon here, the code breaks. It doesn't make any sense. But if we just drop down to a new line, everything is fine. This code will run perfectly. This is because the JavaScript language has something called automatic semicolon insertion, meaning behind the scenes, JavaScript is going to automatically add a semicolon here for us. So as long as we keep our code organized with line breaks and white space, we don't need a semicolon here. Now, I do want to let you know that this is just my personal subjective opinion. In the JavaScript community, this is one of the most hotly debated arguments of all time. The debate of whether we should include a semicolon here or not. Now again, if our code is squished together on a single line, there is no debate. We flat out need a semicolon here, or JavaScript cannot make sense of what we're trying to do. The debate is, if we stay organized with white space and line breaks, do we omit the semicolon here and let JavaScript's automatic semicolon insertion do its job, or do we manually include the semicolons? Now, I don't want to brainwash you and tell you to never use semicolons. I'm just letting you know that that's my personal preference, so you're not going to see me use semicolons in the course. Okay, now that's actually going to bring this lesson to a close. In our next lesson, day 10, the finale of this first chapter, we are going to finally build something practical and concrete. We are going to use the web browser's objects and vocabulary or lingo to build a simple to-do list web application. This is going to leverage everything we've learned so far in the course. It should be a lot of fun and something that you can show to your friends and family. So let's keep things rolling, and I will see you in the next lesson.